Have you ever looked in a mirror and wondered how you can see yourself? Such an odd question, but this is what we call reflection. This is widely known by everyone, but what exactly is reflection? And how does it work? Before we delve into the details, let's first define what reflection is. Reflection is defined to be a phenomenon where light, sound, or another form of energy bounces off a surface and changes direction. Since we are talking about reflection in a mirror, we're going to focus on the reflection of light. The reflection of light begins when a group of parallel rays strikes a surface. These rays are referred to as incident rays. Upon striking the surface, the rays bounces off. The ray that is reflected away from the surface is called the reflected ray. At the point where the rays meet the surface, an imaginary perpendicular line is drawn. This line is known as the normal. The angle formed between the incident ray and the normal is called the angle of incidence, while the angle formed between the reflected ray and the normal is called the angle of reflection. Each individual ray obeys the following laws of reflection. First law states that the angle of incidence is equal to the angle of reflection. It is also denoted by this equation. Let's give an example for further understanding. An incident ray strikes a flat, smooth surface at an angle of 32 degrees to the normal. What is the angle of reflection? Again, according to the law of reflection, the angle of incidence is equal to the angle of reflection. Therefore, the angle of reflection is 32 degrees, as it is equal to the angle of incidence. With the first law done, let's move into the second law. The second law describes that the incident ray, the normal, and the reflected ray all lie in the same plane. This means that no matter the angle at which the light strikes the surface, they will always remain in a single, flat, two-dimensional space. With the laws explained, let's move on to the two types of reflection. The two types of reflection includes regular reflection and diffuse reflection. Let's start with regular reflection. Regular reflection occurs on a smooth surface. Its reflected rays are always parallel to each other, and it produces clear, sharp images. While diffuse reflection occurs on rough surfaces. Its reflected rays are scattered in many directions, and it does not produce a clear image, but rather a distorted and unclear one. Let's put into perspective the difference between the two for better understanding. As we mentioned, in regular reflection, the surface is smooth. On the other hand, in diffuse reflection, the surface is rough, with small imperfections and not as polished. Hence, when an incident ray strikes a rough surface, the angle of the reflected ray changes, making the image distorted. In contrast, in regular reflection, the reflected rays are parallel, which does not change their angle, resulting in clear images. An example of both reflections is still water and wavy water. As you can see, still water perfectly reflects the tree, while wavy water creates a distorted and unrecognizable image of the building. But wait, if the water can reflect, why is the image upside down, unlike a mirror where it is upright? Well, there are two types of images, the virtual image and the real image. Virtual images forms upright images and is always formed behind the mirror. While real images form inverted or upside-down images, they are actually formed by the intersection of reflected rays. There is still a lot to discuss about real and virtual images, but maybe that will be for another video. For now, this is what we'll include. Now, when you think of a mirror, you probably imagine the silvered plate you see at home, but in reality, it can be anything that is smooth enough to produce regular reflection. There are two types of mirror, plane mirror and spherical mirror. A plane mirror is one with a flat surface. In fact, the mirror you see at home is a plane mirror. Images formed by plane mirrors are always virtual, upright, and the same size of the object. On the other hand, spherical mirrors have a reflecting surface taken from a portion of a sphere. There are two types of spherical mirrors, convex and concave. For further explanation, let's create a demonstration showcasing the two. Let's draw a sphere and imagine this represents a spherical mirror. Let's divide the circle into two halves by drawing a vertical line on both sides of the sphere. This side represents the convex mirror. You can easily identify a convex mirror by observing that the curve faces outward, like this. Convex mirrors are also known as diverging mirrors because parallel rays spread out after reflection and never come to a focus. Some examples of convex mirrors are magnifying lenses, telescopes, and camera lenses. On the other side is the concave mirror, which can be identified by its inward curve, like this. Concave mirrors are also known as converging mirrors because when parallel rays strike the surface of a concave mirror, they intersect at a specific point. Some examples of concave mirrors are eyeglasses and binoculars. Now, if you'd like to see an example of both concave and convex mirrors in just one item, take a silver spoon and observe. The inside surface of a silver spoon is a concave mirror, but if you turn it over, it becomes a convex mirror. Now that you have basic knowledge about the reflection of light, I think you're ready for a quiz. Get a piece of paper or write your answers in the comments. Buckle up, let's begin. Number 1. An incident ray strikes a surface at an angle of 90 degrees. According to the law of reflection, what is the angle of reflection? Number 2. An incident ray strikes a surface at an angle of 32 degrees. What is the total angle between the incident ray and the reflected ray? Number 3. A plane mirror always forms an upright virtual image, true or false? Number 4. A convex mirror is a type of a spherical mirror where the reflective surface curves outward, true or false? Last number. Number 5. The reflected ray always makes a greater angle with the normal than the incident ray. True or false? That's the end of our video. I hope you all learned something new today. Thank you for watching.